Hey everyone, welcome back. So in this video we're going to look at modeling the top plates, that being the battery plate, the lid and the top structural plate of the chassis body. And we'll also show you guys how to add in the rivet holes and the bolt holes to connect all the pieces together. So before we get started, I was just going to mention something that I forgot to mention in the previous video. So for any folded part, you do need to consider the shape of the tool that is actually folding the parts. So let's isolate this belly pan really quickly. So this part we call the belly pan. It's one sheet that sort of wraps around all of the side channels. And essentially you can see here that we've got some of these folds that kind of like curl in on themselves. Does that make sense? So it curls all the way in. So I'll just sort of demonstrate something really quickly. So if you can remember from the bending video that we saw in the previous one, you see how this tool basically comes down and presses on the part. So we've got to think about how is this part actually going to be made. If the tool kind of comes in at this angle here to create this fold or this fold, how is that tool going to travel through this space, for example? So you got to think of like what order would these folds be created in, and how would the tool actually access these folds. So I'm going to quickly exit this and remove this sketch. So essentially what we need to consider is the shape of the tool. So if we bring up this image here, this is called a gooseneck tool, I think they call it. It's basically just this specific shape that allows you to do folds that kind of overlap on themselves and curl around. So what happened was initially when I designed the chassis body in 2020, I made the original belly pan fold round on itself too far that it actually collided with this folding tool essentially. So the reason I'm bringing this up is because if you have any of those folds that kind of, there's multiple nearby folds and they curl in on themselves, you do need to consider the shape of the tool. So one thing that I have done, I've modeled the tool in SolidWorks here, just to check that the tool itself can actually access all those bends. So it's worth, I think this tool will be on GrabCAD. I can link it in the description, but that's definitely something to consider modeling in and just checking that all these folds are actually feasible. Cool. All right, so that being said, let's get back into the modeling. So the first thing I'm actually going to do, which I forgot to mention in the previous video, is that this is probably more of an aesthetic thing, but you see how this plate here kind of overlaps. It overlaps this top sort of face here, which it could leave us with sort of like quite a sharp edge there, and it's sort of suboptimal from my perspective. So what I'm thinking we'll do, at least what I did in the original chassis body, we'll actually just do a quick cut on this part to trim those edges back. Alright, so what we can do, with any SolidWorks part, you got this blue line at the bottom of this list. You can grab this blue line and you can drag it up the feature tree here, and this basically takes you back in time. So if you drag it above a certain feature, it'll just ignore all the features that were created after it. So we're going to drag this line up here just above the split line feature. I'm just going to add in these trims just before we convert it into sheet metal. So it's going to convert the outside border, and then we're just going to cut out these two little regions here. This is of course completely optional, but I think it does end up in a nicer looking end product. Looks a bit more seamless, and yeah, just a good thing I thought I'd note and show you guys how to do. So you can always make changes later by dragging that bar up like that and editing the previous sketches. So we're going to make this offset by 4 millimeters, just like a strip along the side, like so. And then we'll exit this sketch, and then we will cut extrude. Oops, zoom in a bit here. Just cut extrude these two regions all the way through the part, like that. And we can just step through the changes. So unfortunately, this has created an error. is actually a really good example. I'm going to leave this in the video. Whenever you have an error like this, don't freak out. It's normally one of a few different things, but it's always good to get the hang of being able to manage these errors and just like not freaking out. So let's jump into this sketch and edit it. So more likely than not, because we edited some of the previous geometry, this sketch might be referencing some edges that no longer exist. And we can see here that there's like these little, the points on these lines have turned like a yucky kind of brown color. That basically means they're referencing edges that no longer exist. So if we click on this point here, we can see the brown color of this coincident. It's because it no longer exists. So we can just delete that coincident. So I normally just go around trying to look for anything that's referencing old geometry that's turned brown. And we can just delete those old relations like that to start with. And we can see that we'll probably have to come in here and redefine some stuff. So I'm just going to sort of attach these points back to the new edges like this. There we go. Now hopefully we'll be able to exit this sketch and it'll be fixed. There we go. So we basically, you just hunt for those little brown points or lines or anything that's over or under constrained. Keep working until you can remove that error. It's always a good idea to, as soon as an error occurs, address it. Because if you sort of leave it lurking, it gets really tricky to track down what change made the error occur and how to sort of resolve that. So that was a good example. And we'll now just come through here. You can see it's converted back to sheet metal. Then we'll go back to the end of our part here. And long story short, I'll turn on all of these parts again. Oops, there we go. And you can see now that the folded part no longer overlaps. It ends neatly at the start of this fold. I think that's much nicer. So I'd recommend doing that if you can. It's basically just not an overhanging lip that can catch on stuff. So that's the main reason we do that, and I think it looks cooler. All right, so now that's done, let's have a look at the top plates. So we're just going to boss extrude these top plates. So I'm just going to start by creating a new sketch. What I might do initially, actually, I might turn on our reference body just briefly, and I'll start the sketch on top of the reference body. And we'll go normal to. And we'll do a convert entities at the top of the reference body. Yeah, let's do that. Actually, what we might do instead, yeah, okay. You know what? Let's not turn on that reference body. Let's turn that off. Let's jump back into a new sketch here. We'll go normal to. All right, now we're just going to draw some sort of outlines for our main parts. So to start with, what I might do, let's start with the battery box and work our way forward. So what I'll start by doing is I'll just convert this face here, and then we can offset this face, this edge here. We'll just select a couple of specific lines. We don't want the chain to offset just these specific lines. So this is a really key thing actually that I'll mention here. So we're going to offset the start of the battery plate by 0.5 millimeters. So whenever we have laser cut parts that are sort of interfacing with each other, like a lid or anything that you want to be removable and just fit together in the first place, it's always worth adding some sort of clearance between the parts. Otherwise, all you need is like a small sort of ding or something in one of the parts and they won't fit together perfectly. So we add like a neat little 0.5 millimeter offset between all of our top plates just to make sure that they all fit in together. So that's a really critical thing to consider, is adding that offset in. Now what we're going to do, we're just going to add a line across here. Excuse me, a line across here and then back to here, like that. And then we'll make this, I think the battery box was 60 across, I believe. So we'll just leave that in there. So that's our battery box lid. Let's now draw the front plate. So we'll just draw a line across here. I might just do this one out to sort of here for now, and then we'll snap it back in later. I believe this plate kind of goes like, how does it go? I think it goes from here to sort of here, like this, I believe. and then we'll follow this line. I'll snap these back on later. Alright, so now that we've done that, we can go around here and we'll make these collinear. And then we'll do the same with this, just so that, just like the belly pan kind of lined it up with the start of this radius, we're going to do the same with the top plate, just so it looks kind of consistent. So we'll shift click these lines here, we'll go collinear like that. And similarly, these ones will go collinear like that. Cool, alright. And then for these ones, just going to add in collinear. I usually like to add in the relations before any dimensions, just to see how well we can constrain this part before needing to add dimensions. So I'm going to make these ones here collinear as well. And then maybe we'll go 20 and 20. It's kind of like a nice round number. Round numbers are good. Like that. Cool. And then let's make this a certain distance from here. Maybe make that 40. Oh, maybe make that. I reckon it was probably closer to sort of 75. That looks a bit better. We'll make this 45. And then we'll just have to make these two equal length. Cool, there we go. So there's our sort of top plate. And then for our lid, we might do a similar thing. So we'll just come around here, we'll offset this line here by 0.5 again to give us that sort of clearance between our parts. Go around here like that. Okay, and then what we'll do, I'll also do an offset on this one, reverse that like that, and then we'll also have an offset there. Cool, and then we'll just join these 2 points together like this, and we'll do the same at the top. Oops, let's do that here as well. Alright, so that's like that, that's nice, cool. Alright, so that's pretty much like the majority of the top plates there. The only other thing I might add in this drawing is just some of our critical holes. So again, totally optional, but I'm going to put the arm holes in this drawing as well. So this the arm holes were on I think it was a 150 by 150 bolt square, which I mentioned in one of the previous videos. And then the distance between the center of that and the center of the rover was 150 also. And we'll set this to here to be horizontal. And then I'll probably just change, all of those into construction geometry, so it doesn't get picked up as a contour during the boss extrude. So we'll just create some holes here as well. Again, could use Hole Wizard, that might be better. In fact, you know what? Let's use Hole Wizard. Let's use Hole Wizard on that down the track. I'll just put a nice big hole in the middle here, which I think we had originally at about 90 millimeters, just for the cables to go through. But again, this is just an example of what we did. Your new designs will be completely different, so this stuff will be irrelevant. But yeah, so that's probably how I would do the top plates if you're doing it again. All in one sketch is fantastic, because then you can just see how all the parts interface right there in front of you. You don't have to track geometry between different parts. So I found that's a super efficient way of doing it. So we'll just exit this sketch, and then we'll just do a boss extrude here. So boss extrude / base, and we can see it's picked up on all of our parts here separately, which is just epic. So we'll flip this around so it comes on the top, and then we'll basically untick merge result. This is quite important. If we merge the result here, it'll actually combine all of the bodies that this new boss extrude is in contact with. Whereas if we untick merge result, it'll create these new sections, all as new bodies, which is exactly what we want. It looks like it's picked up on this rear contour as well, which we don't want. So we'll deselect that. I'll see if I can. So we'll just want this part, and this part selected like that. And then we will click tick on that. There we go. Cool. So it's pretty close. It doesn't look like it quite picked up that edge, so we might have to just address that now. For some reason it didn't select that region as well, but we can add that in pretty easily, just like that. Cool, all right, there we go. So now we've got our top plates. We can see that it's created them all as new bodies here, which is exactly what we want, 1, 2, 3. And these, the lid has these nice, and the battery box, they've got like this groove between them, so they don't catch on each other when you lift them in and out. It's got the clearance it needs. Alright, so we're going to add in the arm mount holes first. So we'll just click on the hole wizard tool here, and we'll select an M6 hole here. We'll go to custom sizing, and interesting how M6 is. Oh, okay, this is a tap drill. So let's go screw clearances here. Let's change this to maybe 6.2 millimeters for our holes, and we'll go through all for the end condition. So let's go to our positions tab here. So we can just quickly, we'll select this face to start working on. Then what we can do, we can open up our previous sketch here. We can show that, and we can add some points. I'm able to convert these points. I think I can do this like that. You can see how it's picked up those locations from that previous sketch to start those holes. Alright, now we can see that these holes, they don't sort of pass through all the parts yet. So what we got to do, we got to go down here and we got to click on all bodies for feature scope. And what they'll do, they'll cut the hole all the way through all these separate components all in one shot, which is really great. So click tick on there. And we can see now that we got these holes that travel through all of our different parts, which is just fantastic. So just so we can keep track of what this is, we'll call these the arm mount holes, something like that. And then we can go around now and add in some rivet holes. So that is the major advantage of creating this whole chassis body in one part file, is we can just click on the hole wizard, and we got these holes that can travel through multiple layers, and they'll all line up with each other, which is just awesome. So it's a pretty robust way of CAD modeling that I'd recommend using. So cool, so what we're going to do next, we'll add in some rivet holes here, and I'll show you how we sort of spread them out. And yeah, I won't do all of them, but I'll just sort of explain how to do some of them, and then you'll get the idea from there. This does take quite a while. So we'll now click on hole wizard again. For the rivet holes, we'll go down to an M4 because we usually use 4.1 millimeter rivets, and we can step this down to 4.2 for our hole size. 4.3 is a bit loose, we've found, so we'll go like 4.1 or 4.2, and we'll go all bodies again for the feature scope. Alright, so for the positions, again, we'll click on this top plate here, and yeah, let's start adding in some holes. So generally speaking, let's start at the back. Yep, so we'll just start by putting a hole in here. So what we've done in the past, we've just gone 10 millimeters from the edge. If you can remember, we made these flanges, like the folded sections, approximately 20 millimeters long, so a 10 millimeters hole in from the edge works quite well. It puts it in the center of that flange. So we'll also add in a couple holes here. So I think for the battery box, we also had a strip of holes there as well. So we'll just pick up on this edge here. We'll go 10 from there. We'll go 10 from here as well, like that. Cool. And similarly for the lid, we're just going to have two holes sort of like there and there, one hole there. So yeah, just like you would with any other part, you just dimension in these hole locations. What we could probably do here is actually use a horizontal constraint between these holes to keep them all aligned, so we don't have to add in all those 10 millimeter dimensions there, so that saves a bit of effort. So we'll just go through here, add in a couple more. I think it always looks nice when you got the holes sort of equal distance from either edge. Goes a long way to making the whole thing look a bit more streamlined, and why not, because you can. So we'll just add in a line now to represent. So you can see here we've got like a gap here between these two plates. So I'm actually going to convert this edge here this edge here up onto this top plate here. And that sort of shows us how close we can put these holes to the edges of those plates. So we'll also chuck a hole in here, I reckon. And yeah, I might just leave it at that for now. So now what we'll do, also set this one 10 millimeters from this edge and 10 millimeters from this edge, like that. Alright, cool. So now all we need to do, we can use a linear sketch pattern here, and we can click on the entity we want to pattern, this one here. We can flip the direction using this button. We want a roughly 20 mil spacing between them, and we'll have 3 along here. So you can see it's created 3 holes there. Now, the neat thing is it hasn't actually constrained it, but it's keeping them at equal distance to each other. So what we'll do, we'll pick up the last one in that series, and we'll constrain it to 10 millimeters from this edge. And what that does, that will nicely space out these holes across that area, which is just exactly what we want. Similarly with these ones, we'll target an approximately 20 millimeter hole spacing. We'll go 3 for that as well. Personally, I think it's more obvious to the eye if these holes aren't equal distant from these edges. It's less obvious to tell if the distance between the holes is exactly 21 millimeters or 20.5. So again, yeah, like for something like this, between here, I'd click on this hole here, maybe we'd go 20 millimeters between the two, probably about 8 holes there. And we'll probably find that, you know, this distance here is not exactly 20, it's like 16. But if we make this 10 rather, you know, you can't really tell that the distance between these holes isn't 20, but it does line up quite nicely with the edge of this part, if that makes sense. So it's just like an aesthetic choice, I guess, but it's probably quite a decent one. And then again, with these, we'll align it to this edge here. We'll just go 20 millimeter spacing, and then we'll go maybe 8 or so, maybe 12, maybe 15, 16, something like that. Maybe we'll go 15. And you know, if we wanted these ones to be 30 apart, or like 40 maybe for double distance, you know, there's no stopping us from doing that. And we can set this here to 10, and it'll sort of spread the holes out a bit more, but it still looks rather uniform, which is quite nice. And you can always edit the number of copies, so in this case you might want to go down to 10, or even 8 holes maybe. So that's essentially how you add holes. Not much to it really, but yeah, pretty darn straightforward. For these holes here, see how they kind of collide through this bottom plate here. So we might actually not want to add in these holes initially. Or in fact, what we could do, instead of doing a through all end condition, we can flip this around here, and we can instead do an up to surface, and we can just click on this flange surface here, and that'll make sure these holes only travel through those top 2 layers, which for these rivets seems appropriate. So we'll just click on the tick there. So that's literally how you do rivet holes. Very straightforward, just using the hole pattern tool. The procedure would just be to continue going around the whole chassis box until all of your sort of overlapping parts have rivet holes between them. So if you can imagine, I'll just do a quick section view here. Maybe we'll flip the section around and go maybe that way, yeah. So anywhere where you've got overlapping parts, so you've got like the top plate here that wants to be attached to this sort of bottom lip, you want to put rivet holes across there so you can actually join those 2 parts together. So similarly, where this central member connects to the top plate, you want rivets along there as well. So the final form, so I'll just exit this right now. What it'll look like eventually is this here. So I'm not going to go through in this video, potentially down the track I'll do a full video, but I think I've given you guys all the tools you need to be able to get to this point now. There's not a lot more to know really. So essentially for all these rivet holes, we just have that sketch on the top, and we've just plopped down where all those holes need to go. For these holes on this face, we would have just started a sketch on this face here, and done a linear point pattern across the bottom here. And yeah, it's really just rinse and repeat from that point forward. So I hope that gives you guys enough information to work with for now. Let me know if you have any questions and whatnot. Always happy to answer them. This CAD model is on the grab card already, so if you need to reference this chassis box, the old one, it's totally there for you guys to reference, so definitely make use of that. Yeah, hopefully this helps, and we'll leave it there for now. Thanks, guys.